Hello, I'm Scott Bicheno, editor of telecoms.com, and I'm delighted to be speaking to Fergus Wills of Enea. Rising energy prices and net zero targets mean that operators now have energy usage and sustainability at the top of their agendas. Most of the energy is consumed by the radio access network, so higher traffic volumes mean more energy consumed. And given how video traffic has been growing exponentially, operators have been looking at ways to cut their energy usage on the RAN and still deliver consistent quality of service to subscribers. Do we think this can be achieved? Well, Enea has recently done a study on this very issue and concluded that operators could reduce energy consumption in the RAN by a remarkable 10%. To explain in more detail, I'm chatting to Fergus to hear more about it. So Fergus, why don't you just start by telling us about your study?
Yeah, thanks, Scott. One of the big things I should just mention at the top here is that Enea has been a specialist software vendor for mobile operators for a number of years now. So we specialize in analyzing network data traffic to and from the internet, looking at how that's changed over the years with the rise of smartphones and the plethora of different devices involved. So Enea as an organization, as a software vendor, selling to putting solutions into the data center of the mobile operator has been at the forefront of understanding data traffic for a number of years now. And as you're saying, I mean, the key point here is how does this translate to energy, literally electricity consumption in the network? So we've been looking at, the study's been looking at the end-to-end journey, literally the request that you would have from your mobile device for internet content. And then the return path, and what at each stage of that journey to and from the internet, big service providers like YouTube, Netflix, Facebook, what is the energy consumption at each stage, and what then can be done about this? Because the rising price of wholesale electricity has meant that this has come to the fore for operators. So it is an increasing cost that they have to set aside money for, so it impacts the business, and they can't. You know, it's not really feasible just to pass on these costs to the end users because we're all facing literally a cost of living crisis out there.
Yeah, we certainly are. So could you tell me a little bit more about Enea's approach to helping operators save on their energy?
Well, I would say what is unique about our solution is that we actually look at the internet content itself. So we spent a long time looking at a lot of the data flows are encrypted, so nobody's decrypting traffic here, but we look at the data flow to and from the internet, and we can identify the heaviest component of that, which is video. So video streaming generally, from our experience, consumes approximately 60 to 70% of everyone's mobile data profile. So if you can understand what's happening in respect to video and literally optimize the flow so that it suits the transmission over the radio network, then you can save bytes. If you can save bytes in the transmission, then you actually save energy in the transmission. The GSMA did a study, I think you were highlighting this at the top, but the GSMA did a study that in terms of the radio network consumption, that is about 73% of an operator's overall electricity spend. Now we know that electricity is sourced from different parts, so it's indicative here, but if we can save bytes over the air, then we can save energy over the air. And what our software does, and Enea is in a unique position here, is it can understand the video flow and then optimize it, literally the number of bytes involved to consume the same amount of video. So I would just say that video is packaged in different ways. We would know it generally in terms of, say, high definition, maybe a high definition TV or standard definition TV. So the different resolutions mean a lot in video. It's packaged in different ways and delivered from the different suppliers, YouTube, Netflix, Facebook, etc., in these different forms. So you can actually take a high definition video and transform it by moderating the flow into a standard definition package. On a smartphone, users can't tell the difference. So you and I as humans, we can't actually tell the difference between high definition and standard definition. Our studies have shown, and we've been a specialist in this for a number of years, that over 70% of people can't tell the difference. between a high definition and standard definition on a smartphone. So the simple equation is if we can moderate the flows, turn high definition video into standard definition video, but keep the same user experience, so you get to watch the same video, then we can save bytes in the transmission and we can save energy.
Yeah, that totally makes sense, because obviously smartphones have got smaller screens,
right,
with a smaller number of pixels that they can accommodate, even the most high-end ones. So that completely makes sense. So I'm wondering if you can give us a sense of how what you've just described translates into sort of value in real terms.
Yeah, that's actually a really good question, because lots of networks are very different in their composition, in the radio access involved, in where they source their energy from, for example, in the different profiles of different users and device mix. So what we did do, if I could just share with my screen here, what we did do was put together a little calculator, which makes it more simple to understand how you can translate this into real value. So I'll just run through a couple of the key variables, and they're also detailed in our report, which is available at enea.com. But what size of network? Enea is sitting in the data center, so we're looking at the network effect here, not an individual. We're looking at the network effect, because we're literally at the interface point between the radio and the internet for mobile operators. So we're sitting in the data center, and we can see all of the traffic. Okay, so simply how many subscribers do you want to serve? How big's the network? So we picked an average size of 10 million. Some are bigger, some are smaller. We have bigger customers and we have smaller customers, but indicative. Just to make the math a little bit easier, let's use 10 million. And then what is the average consumption per subscriber? There's a number of different reports. The average consumption of a European subscriber could be in the 11 gigabytes range. It could be a little less, but in this case, we're picking 10 gigabytes. Again, you can play with this to see if your average subscriber is using less, then you can play with that number. Or if they're using more, of course, then you can play with that number. But let's pick 10 gigabytes. How much of that is video? I mean, essentially, we can optimize flows, we can look at flows, but we're a video specialist. That we're unique because we're looking at the content here. We're not building new radio transmitters that are more efficient. We're dealing with a network that is there and looking at the content that's trying to be transmitted and received by the end user. So generally that's in the 65% range, as we were discussing. So, and then what's the energy? What's the electricity consumption of the network? The GSMA reported this simple number, 0.24 kilowatt hours per gigabyte. So it's a big calculation as to work out for different networks and cooling and climate and efficiency, etc. But this is an average number. Okay, so if you look at the energy efficiency of what the radio transmission is doing compared to what I would have to do in the data center, what Enea has to do in the data center, because we have to account for that. We have to spend a little bit of energy to save energy. Essentially, the difference is about 1,000 times. I can spend X amount of energy in the data center, but I can save 1,000x on the radio transmission. But let's put this in real terms, because kilowatt hours translate to megawatt hours, wholesale electricity translates to cost. Okay, so the GSMA said it's about 0.24 kilowatt hours per gigabyte, and I'm saving gigabytes in my optimization, as we've been talking about for video. So how does this translate to real numbers? What's the cost of a megawatt hour? So that's been the concern for the last year or so because of the various political tensions around the world, as well as climate change. But the real variability in the megawatt hour price, we've seen enormous variability in Europe, in Latin America. Actually, the interworking price in North America has also seen significant change. But earlier this year, it was in the 300 euro range in Europe per megawatt hour for wholesale electricity. We're not talking about household, we're talking about what a big operator would have to buy from the wholesale electricity market to feed the network. So those are the key variables. And then you can, with our little slider calculation here, which is unique, it makes it simple to understand how this translates. You can hit the calculate button and you can see that in this case, it's significant. You're looking at 9 million euros per year that you could save in terms of cost. Again, the cost saving is something then that matters because it makes it gives the operator more money to invest in new radio, more efficient radio techniques. It's not something they have to pass on to their end users. It makes the business more sustainable, as well as saving literally electricity. So when we were looking at this, there's some variability in the cost. It could come down, say, for example, to 200 euro, because some of the tensions in the world are electricity has been sourced from different parts. Again, you're looking at 6 million euro being saved. The idea here is that the tool that we have here, which is again unique and makes it real for the operator, gives a clear impression of what can be saved and how that translates then into real monetary value, cost savings for the operator, and cost savings then again that don't have to be passed on to the end user, or they can use to develop different forms of radio transmission.
Yep, great. Well, I mean, those money savings speak for themselves, and I'm sure, as someone who writes about the operator quarterlies on a regular basis, I know they should be grateful for it. I mean, do you think we've got a sense? You might have covered this already, and tell me if you have. But do you think we've got a sense of how much an operator could save on average?
It's a complex. So that's what we put together in our report. It's a complex scenario in which each operator's blend in their network slightly different, their energy efficient slightly different. So we can produce indicative values, and we invite then the conversation about what this actually translates to for an operator. But in our case, we were in our reports, we were looking at, say, an average operator size of 10 million. You can save at least 10% on the data, at least 10% on the overall data path. You're saving maybe 20% on the amount of video being consumed. So you're saving 20% in the bytes, but watching the same videos, keeping that user experience the same. They get to consume the video on the smartphone. So you can see if 20% of the video bytes translates to about 10, 11% on the data savings, which translates to the electricity cost. Average size of network, 10 million users, you actually save 10 million euro. Right. A little bit dependent on the wholesale electricity price and where they source. Again, these are complex situations which were simple. Yeah.
No, understood. You kind of preempted my final question in talking about inviting a conversation. But if you could elaborate, what should operators do if having watched this video, they want to know more?
Well, I would say that to check us out on Enea.com. We have an executive level report and a more detailed report that actually substantiates these figures. But check out that calculator and slider and begin to think about their own numbers, their own size of network, their own cost of wholesale cost of electricity, and how much they're paying for that. And then consider that attacking this not just from a radio network perspective and getting more efficient radio transmission involved, but using less bytes to give the same user experience is a key additional value that they can add in their search, not just for cost savings, but in their target to get to net zero and to reduce their carbon emissions. It's another tool in the arsenal that they could use. And Enea's been in this game in this specialist area for a number of years now.
Yeah, I think there's no doubt. I mean, obviously, companies everywhere were already sort of working hard to reduce their energy and their carbon footprint and that sort of thing. And the current spike in energy prices, I'm sure, has totally accelerated that process. So it seems like what you're offering is quite timely. Yeah. So that was very interesting. Thank you very much for your time, Fergus. And we'll leave it there. Cheers.
Cheers. Thanks, Scott.